Okay. So I didn't find a good time to stream yesterday, but I did still do a little bit of work. So the main thing that I did is I created this math.h. And this is just redefining the vector and matrix structs. And then for whatever functions I'm using, I am redefining macros for them. And this is simply because I don't want to use this HMM macro or like the HMM prefix for every single thing. And the reason I did that is because I'm having in my source here, in my source, I added this folder. Maybe I should rename it to dependencies or something, right? But right now, the build script, if this folder doesn't exist, it creates it and downloads all of the dependencies. So we have a glue specifically, handmade math. This is the one I was using for math operations. KB, STB, and also JSMN that I'm going to be using today. But if you notice in handmade math, there is HMM underscore VVec2. And I don't want to, like every time I'm having a vector2, I don't want to type that. And additionally, I don't want to edit this file. So there are some things that you can do. I think you can type that, or you can do just a straight like definition macro to replace it. But the problem with that is that you are still using these names. So big E elements, and then you're having the RGB, A, X, Y, Z, W. They're all capitalized, and that's not how I'm doing any of my. It is completely different from the way I'm writing my variables. So instead, I decided, okay, I will have the dependency. Like technically, I could download this, edit it, and re-upload it, but I would be happier to download the dependency and have my own math file that is using that dependency, or maybe some other dependency like for someone else. Like it doesn't have to be that, but this is the function that I want to use for subtracting two vectors, two-dimensional vectors, and in this case we are having a HMM function to do that, but technically I could define it here, or I could use another library to do it. But with this, this code will always have its own definitions for math stuff. So also what that means is that if you're downloading the source, I changed the name, by the way, to Masstronaut. But if you're downloading the source, maybe no. I didn't really. These ones still need to be fixed, I think. But if we open the like build Win32 bat, we can scroll down here. So these are all of the dependencies. It has the name and then a link to the dependency. Glue is a little bit different because it's not just a like Git link that you are cloning. It's actually like a pre-compiled kind of thing, or like the dependency is too complicated to like simply link to and compile yourself. Because the one you get from the GitHub, the Glue GitHub, it doesn't have the C file. Like that's something you have to generate. So what I do instead there is I am downloading the zip. So this is a repository for Glue, and you can literally go to source, and there's nothing here. Like this is something for generating the actual source. And then he is writing down here, oh, the current release is 2.3.0, and 2.3.0 has the C file that I need. And then from that, I can compile the lib that I need and link that statically. So that's what I'm doing. I'm downloading that, I'm extracting the zip, and then I am compiling it using the Visual Studio SLN file, right? And then if it doesn't work, I'm posting some message about it. So in effect, that does mean that at least on Windows right now, if you're downloading my repo, and for some reason my terminal is not working, it's weird. Hmm. Yeah. If you download my repository, you basically do a git clone. Let's go somewhere else. CD. Okay, so maybe not GitHub. Make their GitLab. You can do a git clone, and then it would be GitLab or you can do that, and then you cd into Masstronaut, and then you do a build bat, and then what it does is it's cloning, and it's cloning the external dependencies, and then here you can see it's downloading the zip file, extracting it here, and then it's compiling with Visual Studio. So you need to have that installed. If you don't have Visual Studio 2022, you need to update the path to MS Build right here. But then build succeeded. So if you have Clang, if you have Visual Studio, that should be basically it. And well, you do need to have Git, probably, or like you need Git. You need what's it called? Curl. You need tar. Curl and tar and Git. I think they're part of the Windows since several years. So if you have Windows 10, probably you have all those already pre-installed. Otherwise, you can add them. It's not that hard. But Clang you need to install on your own. Anyway, that's that for that. The second thing that I was doing, like I mentioned, is I downloaded this JSMN JSON, well, not even JSON parser. This is a JSON, what is that actually? Like it's just tokenizer, right? So what I have in my main, I have my parser. I create a bunch of tokens, and then I parse the file, and the file is this text.json. So I have my parent object. I have some count here. This is the number of entries into the data. field or data object, data array, I guess is the correct word. So I have 4 objects in the data array, and what they each contain a language identifier. So this would be Latin, I guess. And then you have some text. You can imagine this is like a intro text or whatever, or character mark dialogue 1. Like you could make that into anything. And then if you scroll down, you have another language. So this is Arabic, and then we have also like some lorem ipsum here. You have Swedish, and then you have a bunch of text, and then you have Chinese, and you have a bunch of text. And this is all UTF-8. And as you can see, you have the same name for the specific text. And it's an array with, this is index 0, index 1, 2, 3. They don't have the same number of indexes. So like I could just say right now, we can do that so that they all have 3. One, 2, 3. So now they all have 3. We can add another one. So like, what would that be? List 1 count 3. Is there a better way to structure this? Or I think I don't actually need that count. I think it's implied in my tokenizer. So like, let's just, whoops, hello? If we just build it, and we can open Remedy. Okay. Do I have to? How do I put it like there? Okay. So you have memory 1 and memory 2. We have watch 1 and watch 2. We have breakpoints can be to the side together with call stack and output. This assembly is not really interesting to me, but we can put it there, I guess. I don't know, maybe something like that. That layout works. Now you can't see the call stack. Well, I guess though the call stack is kind of the least important thing. So let's go here. We can open our tokens. Hmm. So we have the top object or root object, and then we have a string at 5. And if you look here, this is the top object, and then we have a string. It has 5 characters. But it starts at 5 and ends at 10. That's 5 characters. The fact that it starts at 5 is just a coincidence. Then we have the next one, or well, the next token is the primitive. This is the number. And you can see here start and end. So if I do, this is how a tokenizer work. It doesn't actually parse the data. It's just, well, it's tokenizing it. So what that means, as far as I could explain it to you, is that it just breaks it up into like something more manageable. So everything here, this is the start of an object, and then it gives you the beginning and end. And then the next thing that comes is the string, and then you have the next thing is the primitive, raw number, and then another string, and then an array, and then the array has objects, and the object has another string. So it's just like dividing it up for you in that sense. So you can see here, this starts at 0 and it ends at 6,000. So if you want the next object, you know, okay, like I need to find the object that starts at 6052, although there is none. The string starts at 5 and ends at 10, so I can take my JSON file data at 5, the array, or I take that address and get a 10 minus 5, which is, you know, 5. And then it gives me the count. And it doesn't actually have the quotation marks there. We can do a... Now you can see... Oh, no. Okay. Now here you can see the actual characters, C, O, U, and T. There's no like quotes within that. And you can also say STR, or maybe STR goes first. Yeah. And then you also get count. Okay. So that's how the tokenizer works. Like I said, this JSMN thing, it's not perfect, but for what it is, it's pretty neat. And it's also like the entire source is less than 500 lines of code, which is also very neat. And it's, works for C++ and C. And pretty lightweight. They're making some kind of claim. Here, if we go to Jasmine, that's not how you spell Jasmine, which is the original. Is it this one? Yeah. So he is making some kind of claim here. Like, this is really nice. A world fastest JSON parser / tokenizer, which, I mean, I don't really know. Like, it's not really a parser because I can't request the data at a specific kind of data. Like, I can't ask it, hey, give me the third object in this array and bring me the data under the list on the third index, what it instead I have to parse. I have to parse the tokens that it has. And I don't know about the fastest one either. But it's very nice because it's not really using any allocations, zero allocations in here. You allocate the tokens that you need, and then you just go. And then if it runs out of tokens to use, it comes back to you here in the result. This is a negative, and then you are not really you can just like allocate a bigger token count. But for a JSON like this, you know, it's 53 lines is kind of disingenuous because these are several lines on their own. Like in any like reasonable scenario, technically this is all on one line. But like you could say that for a file that is, couple of kilobytes, I'm not really sure, but like maybe 5 kilobytes or 10 kilobytes. What is this? 6 kilobytes, right? So like for something small like that, 256 is like more than enough. But you can have a megabyte JSON file and you can parse all of it, using like KB I don't know, 512. Like that would give you a lot of room. And then you could allocate that using the arena. And if it's too small, I can, because the arena is quite big, I can just do an arena realloc to like double the size or something like that until I find the size that it actually is able to parse. And I'm not sure if I could reuse the tokens that, like, probably I would have to clear everything and then read it again from the beginning. Because I don't think it has a way to say, okay, I ran out of memory. Please give me more memory and I can continue. I think it just kind of like goes in one go. And when it runs out, maybe it tells you like where it ran out and you can make another one. But in any scenario here, I'm going to know the size ahead of time. So I think that just typing this out and asserting that the result is true, and the result here is the number of tokens that it needed to use. So like here in this scenario, the number of tokens is like 30, 40, 50 something. So like this result is going to be like, okay, you gave me a token array of 256 and I used 46 of them. And if it ran out of tokens to use, this is going to be -1. So I'm just going to like print an error message because I'm going to know every JSON that it's going to be handling. And then I can just like increase this if I need to. Now 256 or 512, that fits easily into my what do you call it? On my heap? No. Stack. This fits easily on my stack. But I could also, if I ran out, I could just put it into my arena, which is heap allocated. Anyway, all that said, I guess we will just continue. So we are parsing this entire array. Well, we're parsing the array of bytes, which is a JSON. Now, something that I was curious to find out is if this JSMN could handle parsing, because this is a UTF-8 Where do you go here? This is a UTF-8 file with strings in different languages. And these characters, they could be 2, 3, even 4 bytes, possibly. And same thing for Chinese. And then some of these Swedish ones are 2 bytes in UTF-8. So it's interesting to me to see if there would be any character in here that, you know, in isolation, it looks like it's a bracket or quote or comma or something like this. And then that breaks the tokenization, right? Like you could imagine that here we start the quotes, and then this character in UTF coding just happens to include the character for a quote. And then internally, the tokenizer ends the string right there. Now that shouldn't happen if it was programmed well enough. I don't know if that would actually happen just by itself. And I'm not sure if any of these characters would have it. So like, I guess we could make an investigation. So if I am going here, we're having count. I can do uh, 4 I want to do. And I want the actual character. It's a single quote. In ASCII, it's 34, x22, right? So if we go to this Unicode, we should be able to do 0 and 22 here. This is the character for quotes. But can I do A22? So there's a lot of characters like this. Let's do that and see what happens. That means we have to find the token. So what this is tokens. Well, let's start at 1 dot starts. And then end minus start. And now we can change this to like 3, for example. And where is this H? Roughly. Let's do JSON file dot data or pointer data. Here's the Latin. And then It doesn't know these characters. This is Arabic, so yeah, it doesn't know the characters. There's some quote there, comma, quote. Here's the Swedish one where I added the H, right? So this should be around, what is this? Can I get the offset? I can't copy that. It's annoying. It's like what? 129E748 4FA8. And we can go back a couple. F70. It doesn't support what? $3,700. So something that starts at 37. Could it be this one? 21. Mm, 22. Or actually, probably more like 24. List 125. Tokens 25. Start. One, two, three, four. It starts with the bracket, really? It starts with the bracket. And then you have this, which is correct. That's this one, it must be. And then you have this 7661. I want it as hex, please. What was this? 1E22. E1B8A2. Oh, I think I didn't save this and rerun it. E1B8 A2. Interesting. So this one doesn't actually have 22 in the UTF encoding. Is that generally true? It might actually be true that because these are all negative, right? This is negative in as a car. Yeah. Oops. All these are negative. And if I go to 0, 1, these are both negative. Negative. This is all negative. Or no, this one is not negative. 88. Oh, it is negative. So what is car 128? 80. So F's 7F is the highest number. So yeah, it's all negative. All of them are negative. So maybe there's no overlap. Okay. Then it should just work. And we can continue with the tokenization. Now, I want to make a function that is parsing the entire JSON. Or do I? We can do re-JSON and parse JSON maybe, I'm not sure. Let's tokenize with an S. It's likely with an S. Interesting. Okay. So we have tokenize. Lexico. I don't know what lexico is. Let's just verify. I don't want anything. Yes. So UK usually tokenize computing. So tokenize JSON, and we're doing exactly this. And I'm not. I want these outside. So it needs to have the tokens and I32 token counts. And the file. Car. Do I give the file or the maybe just a file? So we are having tokens. We're giving that to this JSON file. Tokens, array count, tokens. And that's it. And then we parse it. So we give, again, the tokens and the array count of tokens. And, well, it needs to have... So typically, you look for something in a JSON. You give it a path. Like, okay, I want to have the in root slash what do you call it? Texts. And then you can give it something like lang equals en, right? Slash what did I write? List 1 0. So like you would have a sort of like request like that, and then it would find the roots, and then next it would find the in the root it would find the object that has this language set to English, the object with that, and then it would find the list and take the thing from the 0th index. And this can get pretty complicated quite quickly. And I'm wondering to myself if I actually want to write something that could parse this and grab it from the tokens here. Some of it wouldn't be too hard. Like this would be pretty trivial. because we can do, okay, we have the root. In the root, we can find data, and then we can go to index 0. Or, well, that's what this would be. So like either I can do this 2, and this would imply that 0, 1, 2, we would be here. Or I could have a special command like this, where I say that lang equals like that. So it would look for something that's like this inside. And this would be a little bit involved. This would not be too bad. I'm not really sure. And remember that I can pretty much do this also. I don't know. I can't do that. See, the thing is, it requires me to do a lot of string parsing inside the game. The alternative would be that I take the entire JSON and I do this parse, and then I get an object that is, linked or something like that, where I can just like access the, JSON dot. So this would be the root. So it would be JSON.data lang se, right? And then dot list 1, 2. So like, but the problem with that would be that I have to construct this. Like, it wouldn't be called that anyway. It would be like element that object, something like this. And then it's kind of like abstract. I don't really know. Like, I have to just like keep commenting. This is accessing, and then exactly the same thing that I was typing before. Like roots data to text 1, whatever, list 1. And that just doesn't seem like a better way to do it. And it's like overcomplicating it, kind of. So I think I don't know. I guess we can try. Data. And data is what? An array. How does that look? No? I need to recompile it. Error. Warning. Otherwise, return TFL error. No, did I? Why is tokens not found? So we are having objects. This is the root object, and then we have some string and number, and then we have a string, and then we have an array. The array is having, that's the value for the array type. Start and size. So this thing we don't really need to care about. The question would be, how would I write here? Would it be implied? So we have data, and then like what? Should it be like this too, or this? I think that this is very clear. So we can start with that. I do want to have some kind of like finder function like that. I'm not sure because there's nothing to imply here that data is an array necessarily. But okay, let's skip that for now. We can do data, a specific index 2, for example, and we can parse that or try to parse it. Command tokens array counts. Good. So we are having the command, and we're grabbing everything. This will be a recursive function, by the way. That would be accurate. Let's do list one here. We need the name. We kind of need to split it by the slashes. So our name or identifier. It's the command. Well, we need to use a lot of string manipulation here. So we are doing a car strl compare. What is it called? I forget what it's called. Okay. A string character left. Find character. Also, by the way, this is a const car, so let's not make a mistake. What is it called? Car L compare. STR CHR string character. So we are having the command, and the value is slash. This we are end. So right. We also want to know if there is a left bracket or a left what do you call this again? Parentheses. There we go. So we can do a number of things immediately. We can see if does this give back a null pointer? If it can't find it, a pointer to the null terminated byte, a character to search for, null pointer if no character is found. Okay. So there's a number of things that we can induce. Find the shortest one first. And remember, we are ignoring null pointers. Relational comparison. It's unused. It's what happens when you have typos. If n is not null pointer, like that. We also want to find the total length. So I32 name len or identifier len. And this Sterling. There's something like a maximum string length. No. But we can do something like, define max, not max, JSON command length max. And then that can be 16,842, whatever it is. 384. It's a KB16. Hmm. Okay, I need 1 moment, so I'll be right back. Okay, I am back. Let's sit back a little bit and just type it out, because this is going to be a lot of typing. It's not really a lot of thinking, I think. We find the shortest one first. There's no reason not to save these, actually. It's I32 lengths. And this is array count of source. We can initialize to 0. Else Actually, I don't need to do that because I'm already initializing to 0. So if it's not null pointer, we take mm, well, I can do this. Source I minus command. I can do I32, and I can assert that this is positive. Uh, I'm not really sure how to describe that error, but something like that. That should never happen, like it shouldn't start on one of these characters. That would be invalid. That would happen if I would put in a bunch of these, and then I'm parsing this, and I'm like, okay, I'm going to the next one, and then the first character is that. That's like invalid command. Maybe, yeah, I think that's pretty good. And then if len is smaller than identifier len, then just save it. Oh. So then we have a identifier, the max name. Like max identifier. Is that enough? I think it's enough. I can do 1 kilobytes, and then we just pass in our fucking scratch array, because why not? This is arena create. No. Push. Because I want to clear it. No, I don't want to. I want to alloc. Size is KB1. And what? Nothing. When it's telling size in bytes, it's telling so okay. The size in bytes is this, but I want to copy a number of characters. Max count. I can do that. Then I don't care about the maximum. It just wants here we know. Oh. Beautiful. We are going to parse JSON. Let's go there. We can already tell how it's going. The command line 20, good. This is invalid, by the way. I should probably fix that. But it means that this should trigger. So the length for the first one is 7. Well, actually, it wouldn't trigger because right now we're just looking up to that. But like the next time we would go there. For the next command, it would be invalid. So yeah, the length is 7. That's going to be the smallest one because the other ones are null pointers. right? What is the command? Oh, it is not null pointer. This length is more than 7. No, it's 4. Ah, okay. Yeah. Uh, the end of the entire like command unit is that length is longer than the one that has just the identifier plus the bracket, square bracket. So then we get the length is 4. We are allocating that on our Scratch arena. We are copying, hopefully. Oh no. Why is that? Dest size and count. That's exactly what I did. Invalid parameter, invoke Watson. So are you pissed off because the length, like, are we talking about missing a 0 terminator? I have a feeling that's a reason. I don't really have my own library for handling text right now. Something that has the length of the string rather than a 0 terminator. So you can avoid this with a mem copy instead. Then you're not guaranteed to have a 0 terminator at the end. Like it depends on your arena design, of course. This is fine. This is okay. So we get that. We also want to know the rest. So for example, we have a bracket here. That means that we are looking for an array. Well, we don't really care if it's an array or not when we are looking for the identifier. So tokens. We don't super much care. Undefined. That's beyond. Am I not zero? I'm not zeroing it out. Well, this is beyond the count. Or is it? Ooh, it's okay. Okay, much better. Uh, there's something like I think you always have to have a root object. I don't know if this library objects if you would start with an array. Technically, it would almost be like a feature, right? But you could do an assertion at the very beginning saying, okay, the first object has to start at 0 and it has to end after the last token ends, right? And then you're like, okay, then we start from the next thing that comes. And then we start comparing strings. So this string starts at 5. And it has an array. And if it's not this, then what do? It says the size is 4. So we can go here and count. This is one object, but I can't just go to the next object because this might be not part of the, like, I'm just thinking about how do I can jump this entire array to 6038. but there's nothing really there. So let's just add something else. You know, just to fill something out, right? So now we have more tokens, of course. This goes all the way to 6038. So do I skip to whatever is after 6038? Here's the first thing after, because this ends at 6022 and this starts at 6045. So that's after this one. And I could just like do a straight linear lookup here and skip the entire array. Then I don't have to go into the array and find 4 things inside that correspond to it. And I feel like that's how it's supposed to be used. It would be nice here if it, instead of this, had some kind of like index. Hey, then the index after this would be number 35. And then there's also like, okay, so you see here you have a Jasmine string. At, where was it? Here. This is a string, but this is also a string. And the thing is, there are different things. Yes, this is a string technically, but it's the name of an object, or like it's the name of the thing that comes after it. So you have this kind of like, okay, here is here's the name, the identifier, and here's the data, and then you have another thing, and then you have the data, and it doesn't really tell you here. You can tell by the context, but you couldn't tell, or could you? No, you can't tell because, like, okay, if you have an array, then you might have multiple things here, and they are not named. So it's not following like, oh, every even object is the. There's no convention like, oh, every even index is the identifier, and every uneven is the data. You can't do that. So for this specifically, I first have to I do want to try now. I need to do something like assets text invalid JSON. Oops. Let's do that. This is very wrong. This is not correct at all. And actually, I need to change the file. Parse JSON, okay. Load assets, here we go. Invalid JSON. Oh. Three tokens. And it says that it's undefined array and some garbage. So that's interesting. What if we give this a name? Undefined array garbage. I did save it, right? So yeah, it's interesting. It doesn't like assert or anything, but I guess that's a feature. Or am I dumb? Huh? Hold up. User breakpoint. What? I want to tokenize it. My result 6. Ah, invalid JSON. Okay. I wanna see what happens if I don't do that. Six tokens, huh? String array, it doesn't fucking care. Like, just no care in the world. And again, like this, we do the same thing. It's just like, oh, by the way, I found an array. that's fun. But if you look at the like specification, JSON specification, I'm pretty sure it says literally the first thing has to be an object always. Okay, I don't really care. Okay, I don't really know. I don't really care. The question is, do we support this? This is invalid. It doesn't even have the, like, it doesn't even care. It just says, oh, there's 4 of them. And then it doesn't care about the commas not being there. Just goes to the next one. It's an issue because, like, if you consider this valid, then you see the problem. I'm trying to find an object called, you know, X. And the first thing I see is an array, not a name. And then I'm looking at the strings inside of that array rather than the name for the array. And then if that's not, if that's incorrect, then I'm, you know, advancing to the next thing after the array. So it kind of still works, but I have to say, okay, the first thing that I'm looking at is an array. Then, you know, I'm skipping to the next thing. If it's not a string, the first thing, I'm going to the next thing. So I guess the first thing I need to do is I need to find the scope. So I am having my JSON file. I'm giving it this array is the scope. So like you can have something outside of it. And this is part of the same scope. Because technically these are both inside that. Now again, you can't have an unnamed property. so like, okay, what I'm talking about is that if we have this JSON, I give it this, then you know that, okay, this object up to the end is my scope, and anything in here is fair game. And I'm looking for, within this scope, the thing called data. But I don't want, you know, something here, like, I don't want that. That is a very terrible thing. If I would read this data, I would read this data as the identifier or like object name and have this as my data. Like that would be terrible. So I need to keep track of that. And, you know, I'm giving it an object. This is my scope. And I can see, okay, here's data. It's an array. And then I can go to the end of the array and I can go to the next thing. Here's the name, object, name, or object, data, object, data, object. It's an array. I'm skipping that. Object, and then whatever is inside. If I'm looking for a specific name, then I'm skipping whatever is inside. Now, I could say, we're starting here, and I'm looking for the named object. So again, we're looking here. It's an array. We're skipping to the end because the array is not called named object. This is not it. This is not it. This is not it. And then, oh, here we have a thing. So this is a named object. This is what we were looking for. So I'm passing in this object. And then for the next part of my parser, I'm looking for the name. So I'm looking for name object / name, and then I want the data here. So then that would work. But if I'm giving the data, if I'm looking for data, I'm getting an array back. So then I need to have the index of the data, and then that has to have but you can imagine that you have other arrays, some other array, and then we can say nested array. Is this not allowed? Expected comma. You're allowed to have nested arrays in JSON. I'm pretty sure. And these can be like anything. And that's what's making it a little bit tricky. I need to, okay, so I can say I need to find the object at the end of the tunnel. It has to lead to an object or some data. And that's it. So we can assert that. We do our parsing. Actually, I need to change the spec. We come in here. The first thing is an object. So we know already, okay, or well, it has to be an object. It just has to be. So we can just do another assert. I'm not sure exactly what to put here. But yeah, it's definitely invalid if we don't get an object, because either at the end of the tunnel we get another object that we are passing back into parse, or we're getting data that we're giving back. And that is, I guess, also something that I have to think about. How do I, if we are nesting this, we need to go possibly like tens or hundreds of layers back and give back the data that we're looking for. So we can think about that. The first things first. We have the identifier, which is the name. So then we are going for I equals 1, because the first one is the object, remember. I smaller than the token count. And here we can do a bunch of skips. I don't like this music so much. So we start at token number 1. And we see if it's a string. It has to be a string. So, okay, if the token dot, okay, well, okay. I can do a string compare. but I need the length. Mm. If it's a type equals JSMN string, then we get the length is the end minus token. And let's do just JSMN talk_t token equals tokens I. It has no implication for performance because the compiler can just tell, it can just do the best thing always. End versus start. Please don't. And then we do a stir n comp for identifier for to. Well, we need the source data. So we have the JSON source token start. And we are comparing complen. And then this gives back like some bullshit value. Like it's saying, oh, is it larger or less? Like it has to be 0 or nothing. Or we can even do like bool result equals this equal to 0 or something. Yeah, if both are equal, this is equal to 0. So like I can just like get a true or false here. So if they are equal, then that is great. But the problem is I have to find out if it's an array or whatever it is. Probably we need to do this before. However, if it's not a string, this is the interesting part. We are having the token end. So if so while the token end is larger than the tokens I, well, maybe I just use tokens I then. Well, tokens I and um, so what this says is that we are saving the end character essentially, this thing, and we are going through every token in our list until we are reaching I is equal to the tokens count, and if we do, we are breaking, which ends the cycle because the next for loop is going to be outside of this. So we're just like iterating through every token until we're finding the next thing, and then we're doing it again. And I believe that there might be some issue with that. I'm almost certain there's some issue with that, but we can start there. What is the problem? Ah, one problem. Where is the problem? Why is it wasn't showing up here? So let's see. We are doing this, finding the shortest one. Okay, fine. We're allocating our identifier and copying the data. We are looking for something called data. And then for the number of tokens that we have, we're trying to find the string. The length is, ooh, that's no good. That's garbage. Like, this is nothing. Why would it be? So the first one is a string. That's correct. This one. We're getting the length. It should be 4. and it is. We are comparing this with that. That should be true. And it is true, so we are like, you know, probably going deeper into this. Oops. Forgot an important keyword there. If it's not a string, we're doing this. So what I want to do then is if we are looking for that. So we are doing the same thing, but now the result is going to be false. This is not what we're after. So then, well, what do? We kind of need to do, well, we're going to the next thing. But the next thing could be another string with a name. So that means that we need to I can do tokens I, or no, I plus plus, because, okay, this is not the thing we're looking for, but the next thing is what this string is describing. So we are advancing that, and then go to, we can go to here, and we can call this go to end, or like find next token, you know, something like that. Then go to find next token. I think that makes sense, right? So like we're looking at this string, it wasn't what we were looking for. So then we're going to the next token and skip whatever it is. So if it's if it's another string, we skip it. If it's an array, we skip the entire thing. I think that makes a lot of sense. So again, yes, tokens I. Here it's an array, and this array is huge. So it's actually a pretty interesting situation. So we go to find next token, and we just like, okay, we find that the end is at 6038, and then we just skip tokens until we find that that the end is larger. So it's not this one, and it's a start specifically. So 1926, nothing like this. Until we are breaking. So like we can just skip like that and see what is I. It's 36. 36 happens to be Ooh, no, wait. Where we're skipping from 38 to here. We skipped one. Excuse me. We went one too far. How did that happen? Oh, because we reached the end. I see. So we're kind of not increasing this here. We have to be careful of infinite loops. But right now, okay, if it's a string, we find out what it is, or we get what we want. Excuse me. We get what we want, or we are increasing I. And here again, increasing I, like forever, until we find the end. So then we get 35, which is the right answer, because 35 is the first token that has a start and an end. That is after the end of the array that we were trying to skip. So now we do the same thing. This is a string. And we are doing what exactly? We're comparing the thing. Here it happens to be true because this was the next thing that we were looking for. And in that case, we actually do give back what is in here. So are we giving back the token then? The token has all of the like information. I am just returning this. And whenever I am coming back to here, like this function will be iterative. it will be self-referential. What do you call it? It's a the function will be calling itself. What do you call it? Recursive. Thank you. So this will be a recursive function, because in the situation that we're looking for something like this, it will call itself with the next part of the thing after we find it. But I haven't figured out quite how that's going to work yet. But then at the very bottom of that recursion, we return a result, and then we like go back with that result all the way to the top. So in return, I don't know. Undeclared. We can return nothing here. But if we actually have a result, we are returning that. So let's see. Parse JSON. I already used result. No? Let's do that. And then scratch. Do we copy it or use the length? I'm not entirely sure. I just want to see it right now. Failed. So I should be able to just do a JSON file data dot start, and then data dot end minus data dot start, and this is a string. Damn. So what is data here? 645, 653. This is a car, of course. And well, that's the wrong thing. That's the identifier. What I wanted to have was the data. And that's what it was right here. And of course now I can take that string and I can copy it. I can do whatever I want. Um, there is one problem though. It could be an array. So actually what I want to have is sort of a JSON result, I think. So I don't really want to use this. I want to have a JSON result. JSON result like that. I don't know. And this JSON result, it's a const char source. Well, it should be like that. No? So I can do something like this. I think that makes the most sense. So obviously, if the result is another if the tokens dot type is equal to a string, so well, the problem now, let me draw it out for you. Here is my arena. Here's 0x0. Down here is 0x, something. And I have, as I am traversing the recursion here, I am allocating small amounts of memory for the identifier name here. So I'm allocating, it might be, 10, 100, not 1,000 realistically, but like it's, theoretically possible. In total, probably not a lot of memory, like let's be generous and say it's like 1 kilobyte. Okay. Then I get to the point where I want to have my result. And the result could be, well, the result here would just be, something tiny. Like the name, it's going to be like, half a dozen bytes or something. Like, I don't know, 10, 12, 16 bytes. But I might have 100 results. So then again, that's going to be like a kilobyte, block here. Then I'm going back through the entire stack because it's a recursive function. And I want to pop all these, but this memory has to live somewhere. And I don't really have a way to just like put that up here at the moment. And I don't have a way to like, because I wouldn't know how large it is before I start. So I couldn't, like I could allocate what I reasonably believe to be necessary. But it would be much nicer to just allocate it on the fly. However, that requires me to have not a static linear allocator. I would need to have a dynamic allocator, and I don't. So that means I have to, if I want to solve this problem right now, I have to do a U8 or even results. I have to do something like that. And then instead of allocating it here, I can just do, results dot, well, results, not a good name. I hate naming things. Parse. Destination. I can copy that, right? That dot source equals start. So if it's a string, it's easy. Now I just wondered, or I started to wonder, if it's a object, I mean, this is kind of a JSON in itself. And if it's an array, then we do well, the issue is technically an array can be having things of any nature. In my case, I control it. So it's, I can just like not use this. An array with arrays and then objects and data mixed. No, not necessary. But technically, this is valid. And I don't want my code to care about what I want to use. I want it to care about what I'm requesting and if it can navigate to that. So there is a smarter way to do this. If I'm just looking at it here, it says there's 4 of it. So then you have the object, start and end, 1894. So then the next thing would be this thing. And remember, yeah, there's 4 of them. There's a smarter way to do it. I'm gonna have to take a break and eat something. I will be back and try a different approach, I think. So, yeah, be right back. Okay, sorry about that. Let's come back to what we were doing. So if we break this down to the fundamentals, I'm having my JSON. My JSON might have other objects inside. There could be arrays. There could be arrays within arrays. And these all have to be named. So name 1, name 2. Now, does this have to be named? I believe that it should be named, but I don't think it has to be. And it's the same thing. This array it could consist of a bunch of objects. And then you can have multiple of them. And they are not named. So you, of course, you would be able to have an unnamed array within. So this is possible. This is how it looks like. So the biggest thing I need to know, the most important thing I need to know is what is the name? And this is what I'm doing the first thing that I'm doing. I'm finding my identifier that I'm looking for. After that, you know, where was I? Like here, I'm finding the identifier, but I could go on and then just give this if it's an array. So I would have to check if it's an array. and then find that offset. And this entire skipping part renum JSON parse. This thing could kind of be a function. And what I need to know I need the I need this JSMN token. And I need the tokens count. And I can say I can say the same thing like here. Very small function, like inline, maybe even better. So we read the end, and then we do this. Minus I, of course, not 1. So here, am I using this command anywhere? Not really. So let's remove this again. I don't really like it. I think I can make something much better with recursion. So we are doing also. Let's rename this to JSON parse. Redefinition. Oh, yeah. Let's just remove that. Okay. Yeah. So if we are finding the correct thing, then we are doing a JSON parse. Same scratch arena. The command is the same command, except we are adding the identifier length. JSON source is the same. The tokens is the tokens I, and the tokens count is the tokens count minus I. No. 396. So we entered the first depth, so to say, right? This is not really true. So we will remove that, but never mind for now. The command length is 8. What is the command? It's just the name. So we are finding all of those. They are all null pointers because there's nothing. So the command length 8 is the identifier length. We copy that to the identifier. Right. I don't even know if I need to do that. Right now, I'm not even using it. Because this complan could be Something very similar. So then this is the same as it's the command. And then we can OR it together with identifier len equal complen. Thanks. So yeah, that is 8. This is 4. So this is false, but also 8 is not equal to 4. So this is also false. And then we skip to the end. I is, well, I never saved I anywhere. So we go from 2 to 33. I feel like that's not accurate. It would, it's supposed to be 34, 35. The array ends at 38. So why would it be here? So I is 2. 2 is the array. It ends at 38. Mm-hmm. Really? Now we're at 2. I is equal to 2. The end is supposed to be at what? Oh. Yeah. Now it's correct. Same as before. So we go after the array. The length is 8. The result is true. They are the same. And 8 equals 8 is also true. So this becomes true. And then we are having our result. We're going to the next thing. And then we are parsing this command plus the length. And now we're here. And at this point, well, the command is nothing. And if I actually look at it here, it's just a null pointer immediately. So that is a sign that we have reached the end of our goal. We can also see tokens. I want to make this 0 initialized because I just want to see what goes on here. Tokens count 17. So what is token 17? It's undefined. And 16, it's the last one. So that is very good. I like that a lot. But you know, we are having the string length, and the string length is 0. our command length is 0. So that means that we have reached the end of our goal. It's not a assert. We can make it as clear as possible. If the length is 0, then we return something. I could return the index. Not even, because I don't really have the index. I could return the token. I don't really know what to give back. We can return a we can return that, I guess. So this returns that, and then what? And then we go up through all of those. Here we didn't find anything. So you see that works. Now the issue is if I want to return something different, because this is a string, I might return a JSON file, and then I have to parse again. So if I do, so okay, I can return this. Now I want to return JSON object. We get something, JSMN object. And this thing, that's the thing. I could parse this as a JSON again. So that's possible, right? Oops. Oh wait. Well, the file would be different. The JSON file dot data would be this data start. No? This is not assignable. Well, okay, sure. I don't know. Something large. And then mem copy from, well, the destination is the new file dot data from this, and the size is data dot end minus data dot start. And I can actually do new file dot size. And set, reuse that here. New file. What else you need? File type. I don't think I need that. Name. No. No, that's all I need for this test. So new file. Cool. Let's see how that works. So we have our new file. Hmm. Oh no, that's going to be zeroed out. I need to copy it first. It's really good at playing the music I don't want to listen to. I'm starting an album, and then an hour later, it's just playing random music that I never wanted to hear. On Spotify. But yeah. So now we have this. Here's our string. And we can redo this token thing. And we have 5 tokens. And it, you know, it's just it's exactly like I would expect. It's the root object 1, 2, 3, 4, 5. And that's it. So then we need to just return an array. So how do I return an array? The thing is, this thing has the information that I need. So it has the enum that it's an array, and it has the start and end. So I don't know if I really need to do anything more with that. What I need to do is I need to write something about going deeper into the JSON. Hmm. So, well, I'm just thinking, man. Uh, what is in here? If I do data 2, I would expect to get 0, 1, 2. I would expect to get this JSON as a JSON, basically. So we can start there. We are the first time around. This is very good. We're not allocating anything on that in that arena anymore. We're just kind of going straight into it. Of course, every recursion is gonna allocate on the heap, but I can recurve or recurse a couple thousand times before I'm gonna run out of heap or stack. I mean, not heap, stack. I can recurve a couple thousand times before the stack overflows. So if we are coming in here, the second iteration, this will be 0, and the other ones will be null pointers. Or like this will be exactly the same as the command. So the command length will not be 0, so that's fine. But the identifier length would be 0. So we can do like something like if identifier length is equal to 0, then we must say, okay, this must be an array or hmm. I'm not really sure what I'm gonna type. Here's the thing. I can't, if I do this and I just have a bunch of those in a row, then, you know, that's a syntax error, basically. I can't parse that. If it's this, then I'm expecting there to be a number before I reach the end. And if it's something like this, where I have, you know, a request or whatever we were going to call it, where, you know, lang equals, you know, blah, then again, I'm also expecting that to be something. But I think that's what's going to happen. The identifier length is going to be 0. So the first time the identifier length is the name data. And then we have an assertion failed where if the length 0, aha. So it's interesting, right? Because the command right now, this is 3 characters. But what we have found is that the identifier length, or this length, from one of the sources, from this, is equal to 0. And I have disallowed that. So I guess we can just remove this assertion. It's not invalid anymore. This can be 0. Well, obviously I'm going to have to recompile. So if we look at the source lengths, they're all 0? No. Okay, well, they are all 0. That's true, but that's only because these are null pointers. Now it's... I do want to know... This is not a null pointer. Well, if it is a null pointer, I could make the length -1. And let's just do I32A equals 0, because why not? Assertion failed, invalid. Oh no. Tokenize. I see. What happened here is that this never executed. Oh, come on. What is going on? This is where I'm putting the source lengths. Wouldn't it be? So now you can see here clearly there's only one that is valid. This is 0. And yeah, that's it. So now my breakpoint was going to work. And I can see, oh, obviously my I can see quite clearly that it's this one. Now the problem is I might have, you know, a more complicated, you know, let's just put that in there. Just to not make any assumptions. So you can see here's 304. I need to find which one is 0. Which one of them? Special characters. Yep. And then SBC length. Find out which of the special characters is the 0, 1. Well, it's the same. I can just put that in here, actually. I don't have to do the loop twice. I32 0. -1, let's say. So we get that, but we can just like save that. So we don't have to find that out. Now we know, so we can do a switch. 0 special. Case 0. Well, if it's the end, then this is a syntax. Error. We can even say trailing forward slash Yeah. Default is assert, as is typical. I don't even want to call this error. Identifier error. Parsing error. Case 1 and case 2. Oop. Okay, so case 1, the bracket. This is an array. And here, special request, unsupported at the moment. So we can do another assert. Do not forget my new lines, because new lines is what makes it print on in the browser. Without this, you can have no messages, and then you wonder, why is nothing printing? So if it's an array, what do we do then? Well, the first thing we need to do is we need to find the end. So again, from the brackets, I think makes sense. str car. So from the brackets, we want to find the right side brackets. And then we get some value. We can cast that to an I32. This is not safe. So here's the deal. If this is not found, this is a null pointer, and then I'm having like a negative pointer, which is a huge number that would never fit in an I32. So, you know, while this is concise, it's actually kind of a huge issue. Because then this length, it doesn't make any sense anymore. Like, it could be 10, it could be 100, it could be 10 million. And like, even if it would fall into some like maximum length that I'm defining, there's no guarantee that it's accurate. So I'm just gonna have to say car star end. And then if this is a null pointer, it's another syntax error. I don't even need to break here. I can just like return null pointer. So a syntax error, a missing end square brackets. Is there a nicer way to say that? Square brackets? No, it's just square bracket. Okay. So assuming that it's not a null pointer, I am trusting the length. So then I can do this end minus bracket. And that means that we can do I32 value equals strlio. How do you str int sti. There's a system like two unsigned, or is it just like two integer toy str2 or integer? And we are doing, is it not this str2i? str2l, that's the function. Well, so the string is, well, it's bracket plus 1 end pointer. It's the end minus 1. Or is it just the end? Radix is 10. Is this signed? I'm not sure. Long integer. Wait. Let's see what that says. So we are here. We have identified that we are having some kind of situation. And then we are doing our switch. We have found that this is an array, or it's the start of an array. So we find the end pointer, that's that here. We see that the end pointer is not a null pointer, so we are not reporting a syntax error. We can take a and then start to get the length. The length is 2. That is not true. The number 2 has a length of 1. And the reason why is because we're counting the bracket itself. So actually, so let's do car num equals bracket plus 1. Oh. Const car. Well, that's true. But all of them are const. Like, I don't know why you're complaining about this one and not this one. They should all be const. Oh, you don't like to have const cars? No? Is it trying to give me the end? car store and like that. And then I can like just double check. TFL asserts that the str2l end is equal to end. Otherwise, JSON parse the string something like that. Cool. So what now? Well, now we have our value, and we should be able to see if it's correct. No. We got the length is 1. Oh, it's not num plus 1. It's looking at nothing. It's a length of 0. Yes, now the value is 2. That value is correct. And we also have that the end is the same as the end. Beautiful. So that means that we have to advance we're looking at the next, because, okay, here, we are at tokens, we have advanced the tokens a little bit. We are at an array. And we can see that we start and end. So the next thing, the next token is an object. We are looking at the end of that, and we do that 4 times. Skip tokens start at 1. Tokens count is tokens count. And then we get a new integer. There's no I in this context now. So we skip and a hop. Start equals that. And then, well, this assert is going to be here. And then again, we don't break, I think. We can get away with a JSON parse, scratch arena. The command, well, what is the command? The command is the next thing in the list. So that would be the command plus end length. JSON source is, well, the JSON source. The tokens is the tokens start. And the count is tokens count minus start. And then we return that. Yes. I think that actually works, which is crazy. Like, it's a little bit madman type of programming. But I think that actually does work. Let's see. Now I'm gonna get a syntax error, of course. Eventually, but like, we can do this. The length is okay. Well, I guess we need the length is something different. Number length. The command length is equal to this, except this is brackets. So yeah, we skip twice, 1, 2, and then we have our length and we parse, and well, let's look at what we got. We have a string. That is wait. It's 0. That's looking better. It's an object. Really? I'm gonna have to look at that. But if I'm looking at JSON source, that is correct. that is the object I was looking for. Now I'm not sure why the size is wrong. This command length 2 from the bracket. This is obviously incorrect because it's 3. And I even saw a 3 before. Is it this one? SPC lengths. Aha, okay. Well, oops. The command length, this is the end minus start is only like it's +1. Like that makes sense to me ish, like sort of. So the question is, we are going in here. The command now is a /. So we're gonna find out that the special is 0, K0 is a syntax error. If I fix this, this is going to be 0. So we're going to return wherever we are. And, oh, where's this? We return, I hope. That is good. We are doing this. And we get the fucking object that we wanted. And, you know, that's cool. That's real nice. So yeah, I think it actually would. I don't know. I don't think this would work. Right now, this is just a syntax error. Like, even if I'm writing something here, it's going to be, oh, this is the first character. Like, it's going to complain and going to say it's a syntax error. I can even show it. Well. See, syntax error. So, like, it's not that this is a syntax error, it's that this doesn't exist. So that's something I have to fix for tomorrow. So like to do. But that is quite good for being, you know, the beginnings of a JSON parser. So I'm quite happy with that. We can git add, git commit. Started parsing JSON, and what? At the moment, we can get back string objects and array objects, primitives, and primitives and what? Yeah. Oops. Why would it start there? Like I opened up the editor and then the terminal opened up in the okay, maybe I was showing at the start of the day and I just forget to navigate back. That's, I thought it was like 4.5 hours ago, so like I guess I must have forgotten. Okay. Yeah. We My branch is ahead of main by 1 commits. 1 file changed only. No. Nothing to commit. What are you talking about? Anyway, that's it for me today. Let's hope that this is actually pushing it. I hope so. So I pushed 1 minute ago. Main C. Yes, yes. And also assets. Oh, that's not, why is that excluded? Why would that be excluded? Git ignore all JSONs? No. I want to include with JSON, unless like this I don't want to include. So like that. How do I add it back? Git add, and now git ignore. Is this the wrong? No. Like this should work. So I think I think what it's doing is assets isn't actually having any files after you exclude JSON. I'm not excluding the TTFs, so like that's all up there. But this. Can I unignore like that? Like okay, that works. Like that I can do. That I can do. Okay. So there's a git ignore comment. Comment character is hash. Or pound. This all right. Git commit. Specifically from the assets folder. Also, we can copy that. Git reset because I think I think this is not going to be staged. Git add, git commit. This can be a capital git push. There. Now we go. There we go. So yeah, thank you very much for watching today, and I'll see you tomorrow. Good night.